Very good. Well, this is our first in a series of webinars. We did a short informational webinar to the, some of you have come back, and welcome back to those of you who found out and want to know a little bit more. Today, on the line, presenting at various points during this webinar, my name is Mary DeSalt. I'm at the Smithsonian Astrophysical Observatory, and we are a co-I institution to NASA's Universe of Learning. We're a partner on the project. Here at SAO with me is Erica Wright, and she'll be monitoring the chat box. Should you have any technical difficulties, you can, or you have a question and you want to interrupt the current presenter, you can use the chat box and Erica will interrupt us for you. On the line from Space Telescope Science Institute, which is the lead institution for NASA's Universe of Learning. It's the home of the Hubble Space Telescope. And here we have Tim Rue, who is the Senior Informal Education Specialist and leading this Informal Education Network project for Space Telescope. And also Brandon Lawton, who is a astrophysicist and scientist who works on education and outreach at Space Telescope. Also on the line, but at least on my Zoom box, muted out in terms of video, is Natalie Wimberly from Smithsonian Affiliations. And she is, of course, from whom all of you got your invitation to this webinar and will be helping us coordinate the project as we go along. Now, I want to just say a little bit about who all of you, at least what I know about all of you. Thank you for typing in the chat box about where you are from. Looks like we have kind of a bimodal distribution of familiarity with NASA astrophysics, and I suspect that those of you who are from astronomy or space education institutions are on the moderately to quite familiar side, while some of you are in the not familiar side at all, and that's great. In fact, all of you, whether or not you're familiar with NASA's astrophysics missions and the research questions and the key themes of exploring the universe, partnership, expertise in reaching your audiences, in the kinds of informal education that whatever discipline your institution focuses on can really enhance NASA's Universe of Learning resources. So we're glad you're here. Okay. Today, we'll basically be going over the essential elements of this NASA's Universe of Learning Smithsonian Affiliations partnership. One of the essential elements is that we hope to connect you to lots of learning resources. And so we'll give you an introduction to some of those today. A key part of the program is the development of program models or project models. And we'll talk about, give you some examples of that. But today's webinar, in terms of introducing you to the science themes of NASA's Universe of Learning, Brandon's going to give an overview of the big science questions that drive discoveries by the space telescopes and NASA researchers exploring the universe. And then we'll talk about next steps. So in terms, I guess in terms of the essential elements of the partnership, on the left side is what we're bringing to the partnership, and on the right side is what we're hoping you bring to the partnership. So this series of webinars is meant to provide professional development and some learning on how to access and use a bunch of NASA resources that we know about and have created and our partners have created. The project brings a pot of mini funds, modest funding to kickstart some sort of effort on your behalf to implement a program or project model at your institution. We're trying to cultivate a community of practice to discuss your ideas, and we also have access to scientists and educators who can help guide you and provide advice or connections for projects as you develop them. So we're hoping you participate all along the way, either live through these webinars, when we hope you do participate live. The webinars will be recorded, and there's the online community practice that I believe Erica has sent you login information. At the end of the webinar series in December, we'll open up an application for those mini funds. We hope you'll all apply to develop a program model using the resources we talk about during the webinar series. And a key part is, because the Affiliations Network has such a diverse group of informal educators with great strengths, we really look for you to help us share these ideas you've developed with the wider community of museums and other informal learning institutions. So Tim, I'm going to actually stop, I think, my sharing and have you start yours, because I think you were going to go over some NASA's Universe of Learning resources and tell us a little bit about what it is.
Yes, and I want to make sure that you all have a chance to see some of these resources out in the wild web rather than just through some PowerPoint slides. That's showing up for everybody right now? All right, awesome. So first off, before I go into what those resources are, I just want to briefly mention what NASA's Universe of Learning is, since this is a new concept for many of you. So this is formed out of a cooperative agreement from NASA's Science Mission Directorate and these 5 different organizations that you see at the bottom. Space Telescope, where Brandon and I are, IPAC, JPL Exoplanets, Smithsonian Astrophysical Observatory, excuse me, yes, and Sonoma State University. And we are all working on different resources from all of NASA astrophysics missions, not within this NASA's Universe of Learning, not just those associated with our institutes, although we do a lot of direct work with the sciences, which is great for you guys because it means you've got easy access to many of the astronomers and engineers and other subject matter experts who work in this field every day. So we, as NASA's Universal Learning, are providing resources and experience that let you as educators, as museum professionals, engage your audiences in the science, the story, and the adventure of NASA's explorations of the universe. And we want to let you guys help families, lifelong learners, everyone really become enabled to discover the universe themselves. So we're going to show you a few of those resources today. Some of the ones that we mentioned today we'll be mentioning again throughout the webinar series, but we are by no means limited to these couple I'm showing you today. So first off, NASA wavelength. And I'm going to go ahead, and if you see me looking to the side, that's just because it's on 2 screens, so sorry about that. I'm going to go ahead and go right to NASA wavelength. Now this isn't a NASA's Universe of Learning product, but it is a NASA piece, and many of our resources you can find through here. You can also find a whole lot of other resources associated with this. I meant to mention on that last slide as well, when we say astrophysics, that means space beyond our solar system. And that's what we are focusing on in terms of content. Brandon will talk about this a little bit more, but that's a point of confusion for a lot of people. Astronauts are just a little bit too down to earth for us. So we're really trying to have you guys reach for the stars here. So NASA wavelength. There are a lot of different resources in here. The most basic thing you can do is use this basic search on the site, and you can search for any piece of content or type of thing, and you'll notice it's going to give you a list of a whole bunch of different sorts of resources. Some of these are ours, some of these are other people. They've generally all been vetted by NASA, and you can tell that there are going to be some quality stuff on here. You can click on any particular resource, and it'll give you a little more information about it if my internet's working. And within here, you can do a couple things. You can go directly to the resource and see what it is in full and access it. You can also add it to a list. There are a bunch of people who've gone through and made lists, collections effectively, of different resources, and including us. So that may be something useful to do. Let me see if it's still here. There's a list recently that NASA Wavelength put together from the American Library Association conference. And if you look in here, you can see Eyes on Earth, which is one of the resources we're going to be talking about. Well, the Eyes on program in general, or Women in Science. This is done by the folks at Chandra and SAO, and you can get this wonderful downloadable poster set. So there's all sorts of things. Also of note on NASA Wavelength, going back to the original page here, NASA Wavelength, there are some categories. So you can see some different grade levels, and there's also an informal education section. So these are things made specifically for uses within museums, science centers, libraries, etc. So that may be a good place if you're looking for something designed for your audiences. All right, so that is the first one. I'm going to jump to Astro Pics. Astro Pics is one of the things that we do put together. And this, you're going to see all sorts of beautiful astrophysics images throughout these webinars. We love throwing them up on the slides because they're just pretty to look at. And when we're pulling them, we're actually going through Astro Pics ourselves. This is basically a collection. Currently, there's about a little over 7,000. There's more being added all the time. Images, and they've got different information within them. So let me click on one of them. So here you can see an image of NGC 2997. And on the right-hand side, there's all sorts of useful stuff that you might like. You can see the image full screen. You can see where it is in the sky using Worldwide Telescope. You can download it in a bunch of different resolutions. So if you need a high-res version, it's right there. You've got a few details on the image. You can see the facts about where it is in the sky, and you can even see where what the different colors in this image map to within the actual astrophysics data. And we'll talk about that more as we go along. Another important thing to notice on Astro Pics is the search box in the top right. You can see what I've been searching for recently. And say you know, oh, well, I just want to see the Pinwheel Galaxy. You can go ahead and search for it, and you'll get a bunch of different images of the pinwheel, all sorts of different telescopes and instruments, and you can use any of these images for whatever you want. NASA stuff is free to use, however you'd like, pretty much. And if you want to be more general and search for a galaxy, you can do that as well. There's all sorts of information. Now, we do have more pictures and other things at some of the mission sites. For example, you can go to Hubble site, or you can go to the Chandra Telescope website, or Spitzer's, and search for images specifically there. There are more than these 7,000 throughout, but these on Astro Pics have all of this additional metadata and tags and other things which help make it really useful and convenient for you. So I'd recommend starting there. Next up, Eyes on Exoplanets. This is an awesome online resource that's pulling data every day pretty much from newly discovered exoplanets and showing them where they are in our galaxy, how they've been discovered, some information about them. And you can see this model that you can kind of move through and see the planets orbiting their stars and skins attached to them. There's also a kiosk mode. I know this is showing up in a number of museums across the country. We'll talk about this and actually show it to you in a little bit more info as we go through the webinar series. But I'm not going to pull that up right at the moment. Instead, oops, where'd we go? I'm going to mention view space. Apparently, I'm having problems clicking from place to place. View space is another thing that's in exhibits at a little over 200 museums, science centers, libraries, places like that across the country. There's some automatically updating video content. There's new stuff being pushed out every week. You can just basically turn it on and you have an astrophysics exhibit playing for you, and you don't need to take any action yourself, and it's completely free. It's really awesome. If you'd like access, email me. And we'll set you up. We're also piloting some interactive portions of this, and these can be very useful. So, for example, here we have what we affectionately call our sliders. This is the Eagle Nebula. You can see it in visible light here. And these little things at the bottom can be pulled across, and you can transition from one view to another. So now you're seeing the Eagle Nebula in infrared light. And this is this giant cavity and this huge cloud of dust and gas, which is being carved out by some stars. And you can't see the stars too well in this view, but if you're able to transition into the X-ray view, you can see exactly where those stars are that are creating this huge bubble of gas and how they interrelate. So there's a whole bunch of different images in here. It's a fun thing to explore. If you'd like access, let me know and we'll get it to you. Same thing, we'll be making sure that all of these resources are on the Moodle so that you can access them later. I'm going to mention one more resource today, and this is one that some of you may be familiar with if you've done programs like Coloring the Colorful Cosmos. I'm missing that name up a little bit. Mary will correct me. But Micro Observatory has had lets people capture their own astronomical images using actual telescopes. They'll go out and take robotic telescopes that'll actually go and take out pictures for you that very night. And there's a whole number of different targets, and it helps you can set some of your own parameters and figure out those images. It allows the people who use it to manipulate that data to create their own images. And you can also play with some pre-made pictures and create full-colored images, or you can interpret them in your own particular way, add your own artistic flair. Again, one of those things that we'll be talking about a bunch throughout the webinar series. So we just want to give you a brief glimpse of what some of these resources are. Think about them. Think about how you can adapt them to your own needs and your own audiences as we're going through. We'll be talking about different ideas. We'll hopefully have some brainstorming sessions as we're going along. But we would love to see what you guys can do with all of this. And any ideas you want to discuss with us, we'll help craft that application so that you can get some mini funds and actually implement these great ideas that you have. Last thing I'm going to mention is that Moodle Online. Please go there. We want to see your expertise and creativity around these resources, and talk to us during these webinars. We'd love to hear your ideas and your questions and continue that discussion online, and hopefully we'll be able to have some we will be able to have some time for you to ask questions and participate today as we go along. So with that, I'm going to pass it back over to Mary. If I can stop sharing somewhere. And Mary, if you can if you see a place to steal control yourself, please feel free. There you go. Good job. Mary, you're muted if you're trying to talk.
Thank you. Yeah, so let me go through, get us to where we're going. Yes, all right. So in addition to exploring resources through this webinar series, we're trying to give you ideas for program models that you might develop using these resources. And that's really a key goal of the Mini Fund Award program. So examples of program models that other institutions have developed. There's a whole suite of resources called Girls Steam Ahead with NASA, and some institutions have adapted those to create their own program for girls around astronomy and women in science. Other institutions have actually used the resources and images to develop an exhibit, either a kiosk or a small exhibit, something like an event series using the universe of learning resources, either including subject matter experts or scientists that we might connect you to, and resources is perfectly good and appropriate program model. Some institutions have developed summer and or week-long camps or workshops for different age audiences. Others have developed engineering design challenges focused around the space telescopes that we'll talk about that are making NASA discoveries. Let me just give you an example of a specific program model developed by one of your affiliate colleagues, who might even be on the line, I think, in the Springfield Museum of Art in Ohio. Developed a program called Artful Exoplanets, in which they used the eyes on exoplanets visualization that Tim talked about. They used the micro observers that they engaged. It was kind of a camp program, engaged students in using our robotic micro observatory telescopes. Used the NASA space tourism posters as examples of visualization and artwork that NASA does to communicate science ideas, and also recoloring the universe. In fact, the picture on the top left is of a student learning coding behind image processing. But the museum brought their own expertise in facilitating arts education, in teaching the participants watercolor painting techniques that they could use in creating their Artful Exoplanet posters, and their expertise in building connections between the visual arts and STEM disciplines. I don't know, Annette, if you want, I think it's a good opportunity. I'm going to unmute you here if you want to say anything about that program model briefly.
It was a really good experience for our kids, as well as the two of us adults who ran it. It was so exciting to use the interactives, and we just learned so much. We, including the two adults, who one was a scientist. I hired an intern from our local university, and so she was my science person and I was the art person. It was just a really, really good experience.
Great. So that, with that endorsement of what you might get out of participating in the program, I'll move along here if I can get my mouse back on the, there we go. Excellent. So now we want to transition to introducing you to the actual science of NASA's universe of learning. And Brandon, let me know, do you want to move the slides forward, or do you want me to do that for you?
Yeah, so how about this? How about I take control, and while I do that, maybe we open it up for some questions before we go forward?
Great idea. So Brandon, I'll let you do that. And does anybody have any questions at the moment while Brandon gets his slides up on the screen?
Free to unmute yourself.
Right. If you're talking, we're not hearing anyone. So well, Brandon, I guess people are waiting for more.
Okay.
But again, if questions occur to you, feel free to type them in the chat box or save them. We'll be sure to have time for them in a little bit.
Okay, great. So can you all see my screen? Yeah, okay. So again, I'm an astronomer at the Space Telescope Science Institute. I'm a member of the NASA's Universe of Learning team. And throughout the webinars in the next several weeks, you'll be hearing from various, what we call subject matter experts, but various astronomers that are affiliated with NASA on their science as we try to address NASA's big questions that you see on the screen here. These are the fundamental questions that NASA astrophysics addresses. They are questions that are very fundamental in the sense that humans have been thinking about these questions for centuries. Things like, how did we get here? How does the universe work? And are we alone? Now, I put those questions there. I also put on this particular slide some little, I guess you call them little postage stamp-like things of various missions. The way that we address these questions, of course, is we need tools to answer, to investigate the universe and answer and address these questions. And these tools include, of course, the space telescopes that NASA has available. And these are some of them that you see on the bottom. These are not all of them, these are some of them. But this is the idea. NASA's Universe of Learning, we provide a direct connection to NASA science through our institutions. And so we provide that for you. So when you're thinking about program models and when you're thinking about things to do, just keep in mind that we are very happy to connect you with any of the science data scientists from these missions that cover NASA astrophysics. And again, to remind you what astrophysics, what we mean here, as Tim was mentioning earlier, that's anything that is beyond the solar system, okay? All right, so how do we address these big questions? Well, in NASA's Universe of Learning, let's see if I can go to the next slide. See how there we go. In NASA's Universe of Learning, you'll see the big questions at the top. We address these three fundamental questions in the science content themes you see below. And so through the webinars, we'll be addressing all of these science content themes. The first cross-cutting one I want you to notice is actually one that covers, it's kind of listed at the bottom there, but it covers all of the science content themes. It's how do we know? How is it that we are able to make inferences or understandings of the universe? How do we know what we know? And then you'll see the other content themes there. They include things that fall under extreme physics, life and death of stars, the history, origin of the universe, structure, makeup of the universe, other solar systems, other Earths, and I think it's covering up, but I believe that's cosmic mysteries. Yeah, cosmic mysteries. So those are our science content themes. And just for this webinar, we're not going to go too deep into any of them because we'll get into the big questions in these science content themes in the future webinars. I just want to touch a little bit on each of them just to give you a flavor. So let's go to the next slide. The first one is our cross-cutting content theme, which is how do we know? Now, this one really gets to the science process skills and how we do what we do. And they include those things that you see to the right there on the slide. Of course, we have evidence. We have something that we could term something like an astronomer's toolkit, but that's basically the tools that we use to get that evidence and to make things like observations. So telescopes would certainly be in our toolkit. Certainly computers and data analysis software and various things would be in that toolkit. Thankfully, the universe has provided us with constant physical laws. The universe is not changing, certain constants at least, are not changing over the time period that we can study the universe. So we can make inferences on how the universe works based off of those constant physical laws. We can create models and analogs of the universe to understand the universe by applying mathematics. And there's also of course, the fact that it's humans that are doing this. Okay, so there's a global human effort undertaking this, and from our perspective at NASA, of course, we're a U.S. space agency, but this is a global human effort that's undertaking this. I just put one example of the astronomer's toolkit and evidence on the screen here. Just one of those examples would be, of course, the use of light and our space telescopes to capture light. And so just, we'll go into more of these, but for this particular one, because it's very fundamental to what we do, right? Light comes in a variety of energies, a variety of wavelengths, a variety of colors, if you will. And there are the visible colors that our eyes can see. And then there's colors that are higher energy and lower energy than what our eyes can see. So what you see at the very bottom is an image of the same galaxy. I believe that's the Whirlpool Galaxy. That's the Whirlpool Galaxy. So, if you want to go and look it up on Astro Pics, you can find all of these images there. But this is the Whirlpool Galaxy, and you'll notice that you'll notice that it looks different if you look at it at different energies or colors of light. So the visible light, the kind of light that our eyes can see, is in the middle, and that part of the galaxy, you really see a lot of the stars. The collection of billions of stars, you can't see them individually. They're too small to see individually, but the collective light from billions of stars is really what makes that galaxy light up, makes it bright. And you also see these dark dust lanes in that galaxy. So that's the absence of light, the shadowing of light from this dust that doesn't glow in visible light. But if you move into the infrared, into lower energy infrared, you'll see that that dust is actually glowing in infrared. Right, and then if you move into radio, you'll see even cooler. You'll see molecular materials, and you'll see molecular gas, and you'll see even cooler things. If you move into higher energy light, you'll see ultraviolet. Right, so that's really probing the star-forming regions in that galaxy where new stars are being born. And then if you move to even higher energy light, X-ray light, you're going to see some more exotic things. You're going to see regions around very massive stars. You're going to see regions around black holes, regions around dead stars, some of the more exotic things. And what's not covered here, but there's also light that gets even higher energy than X-ray, which is gamma ray. You can also study the universe in the highest energy light called gamma rays. So really, the universe has secrets to tell us, right? If we look at all of the colors of light, if we put those pieces of the puzzle together, we'll really truly understand what's going on in the universe. And so that is why we have so many different types of space telescopes, because they can't all look at all the types of light. It takes different technology. So we need telescopes good at looking at visible, telescopes looking at ultraviolet, X-ray, and so on. That little thumbnail above just shows you why it is that we put telescopes in space, which is to say that many of these types of lights, the colors of light you see down there, many of those energies can't get through our atmosphere, thankfully. Thankfully, our atmosphere blocks some of the ultraviolet and the X-ray and so on. So for many of these regions of light, you need telescopes in space to observe them. And what that graphic above is showing is how far down in the atmosphere each of those types of light can probe. So for example, you'll notice gamma ray and X-ray does not reach the ground. Visible can reach the ground. Some infrared and radio can reach the ground. And even if it can reach the ground, we still like to put telescopes in space, like we do with Hubble, because the atmosphere actually provides like a fishbowl effect and actually warps what we see from space. And so that's what causes the twinkling of the stars, is actually the light bouncing around in our atmosphere before it reaches us, and it can make the image blurry and so on. And so even for light that can reach the ground, you get better images if you go to space. So all that to say that that's why we have all of these space telescopes. That is why we like to put them in space. And we'll get into more examples of how we know what we know. But that's just one of the fundamental ones, is light, or what we call the electromagnetic spectrum. All right, and then I will take a little bit less time on the other content themes, but we're going to cover things like extreme physics. For example, the deaths and the afterlives of stars. These can be some extreme events in the universe. A star exploding can sometimes be brighter than all the other stars combined in a galaxy. So these are really extreme events happening. Black holes, very extreme places in the universe where you have very dense material in a very small space that exhibits extreme amounts of gravity and so on. And gravitational waves, which is a new way for us to understand the universe, that we are finally able to use to probe the universe. And so this is not light. This is a different way of understanding the universe. So We'll be looking at extreme physics. We'll be looking at life and death of stars. So we'll be looking at areas where stars are born, like in that nebula, the Lagoon Nebula you see on the left. That's a region where all that gas and dust you see, it's like a cocoon, it's like a stellar nursery. There's new stars being born there. Stars, like humans, are born, they live their lives and they die, but on longer time scales. So after millions to billions of years, stars will die. The most massive stars die after just 1 million years, and they explode as these brilliant supernovae explosions, like you see on the right, the stellar death image of the Crab Nebula. That's a multi-wavelength image, a multi-colored image. So we'll be looking at life and death of stars. We will be looking at the history and the origin of the universe. For example, the image on the left is actually an image of the early universe. It's what we call a deep field. And all those galaxies that you see there are actually in this big cluster. And if you look at different colors of light, visible, X-ray, infrared, you can probe different parts of that cluster of galaxies. But what's interesting to know is that when you look at the distant universe, you're actually looking farther back in time. And this is a concept that we'll come back to several times during our webinars. But telescopes are like time machines. The farther back and the farther away in space you look, the farther back in time you are looking, because light takes time to travel. So the light from the most distant objects takes longer to reach us. So when it finally reaches us, we're seeing a snapshot of that object as it existed sometimes billions of years ago. So because of that, we're able to probe the early universe. Likewise, if we probe different epochs of our universe, from the early universe to present day, we're able to observe how galaxies change with time, how they develop, how they merge together, and so on. And again, galaxies are the locations of stars and planets and things like that. We live in the Milky Way galaxy. There are hundreds of billions of stars just within our own galaxy. Our galaxy is interacting with other nearby galaxies. If we look at the billions of galaxies in our universe, if we start to piece together, different images of them, we can sort of get an idea of how galaxies change with time and what that means about the origins of things like our own solar system. We are going to study the structure and the makeup of the universe. This is some basic information like the hierarchy, starting at smaller scales, like stellar systems, like things like the size of our own solar system. There's a little artistic rendering of a forming new planetary stellar system there on the upper left, which then, of course, exists with billions of other stellar systems within a galaxy, which is just one galaxy within billions of galaxies in a galaxy cluster, which, if you zoom out far enough, you actually get to what we call the cosmic web, the largest scale view of our universe, where on that lower right, it's a mathematical model of what we think the cosmic web looks like, where each tiny little dot is actually a galaxy or a cluster of galaxies. Okay, so we'll get a sense of hierarchy, and again, we'll get a sense of size and scale of our universe. We'll explore other solar systems and other Earths. So, we have our own solar system, but now we're finding thousands and thousands of other stellar systems in our own galaxy. So we'll explore, how do solar systems form? Like, there's a picture here of this Beta Pictoris, that's the name of the star, and Beta Pictoris b, which is the name of this exoplanet going around the star, which is being pointed to by arrows of different times. So it's positioned in 2003, position 2009. But what's really interesting about that is you'll notice this big bright blue disk. That's actually a debris disk in that young star system, from which that planet was formed and from which other planets may form. And we think our own solar system may have formed from this similar mechanism billions of years ago. And you'll get we'll explore exoplanets and in detail, including their orbits and characterization of them, the diversity, what are the different types of exoplanets out there? Do they match the planets in our own solar system, or are they very different? Could some of them be habitable like the Earth? What do we mean by habitability? What do we mean by the search for life? We'll get into all of those topics. And then the last one that we'll cross are cosmic mysteries. This is sort of fundamentally a bit more obscure topic, but it's really interesting. These are sort of the edges of what we know, what really excites a lot of scientists now. Things that we know are out there, but we don't know the answer to. Things like, what is dark matter, which makes up roughly 30% of all matter energy budget in the entire universe. We don't know what it is. Even more than that, what is dark energy, which makes up almost 70% of the matter energy budget in the universe. We don't know what it is. We see its evidence, but we don't know what it is. What is the fate of the universe? We now know that the universe came from something that this phenomena we call the Big Bang, but what's going to happen to the universe in the future? What do we know about that? How do we answer that? And of course, are we alone in the universe? So this hopefully just gives you a flavor of the types of content we'll cover. And in the upcoming webinars, again, each of the upcoming webinars, there will be 2 webinars for each of the big questions, and we'll get into that in the next upcoming slides. And so for that, I think I'm going to, do you want me to leave this on? Okay, I'll just leave this on and you can tell me when to move it.
Great. Thanks, Brandon.
Mm-hmm.
Yeah, so that's kind of an introduction to some of the topics we'll be going into over the series of webinars in the future. So today was your introduction. On the 19th, in 2 weeks, we will be starting to look at that idea of the structure of the universe, putting the universe in context. We're going to take a visual tour of our cosmic address, which I mentioned in the chat box, kind of this idea of that we are part of a solar system that's part of a galaxy, or solar system that's part of a star system called our Milky Way galaxy that's part of the universe of galaxies. So we'll also give just a little brief historical context as well. And then 2 weeks from that, we'll really dive into this idea that it's a multicolored universe. It not only colors across the spectrum that we can see, but across the spectrum that we can't see, but develop space telescopes. So this is kind of the series of themes that we'll be looking at through the webinars, and each webinar will examine some educational resources in detail. Carol from the Museum of York County, your question about, want to know about what objects you can view in a small size telescope. We have one of those. That's exactly the kind of question we can go identify some resources for you. And I think we do highlight in a later webinar some resources called universe guides or universe discovery guides, which were put together with funding from NASA, and which really highlight by month what some target objects that you might look for that fall under some of these themes. So again, the PowerPoint, somebody just asked, will be made available apart from the recording. So on that community of practice, which if you don't know what I'm talking about when I say that community of practice, or when Tim says the Moodle, there's a URL to give us your email so that Erica can make an account for you on this community of practice. And it was in the chat box. There seems to be at least 1 or 2 people who are on the phone. And so if you can't see that chat box with that SurveyMonkey URL, you want to email either Natalie at the affiliations office or Erica here at FAO to be able to sign up for that community of practice. And if you can forward the slide, Brandon, the next steps. Brandon, can you forward that slide? Because I can't.
He's also muted and doesn't realize it.
All right. So the next steps are, we want to make sure that you're on the asynchronous community of practice, because that's where we'll also post these recordings and the slide sets from these webinars. And so you want to have access to that. and we'll start a discussion thread asking, do you do any astronomy at your institution, and what does it look like? And we'd love you to contribute to that discussion thread. Are there any questions? Great question from Kevin from U.S. Space and Rocket Center. And in fact, we have an answer for you that you'll like. Kevin asks, are there any plans for adding FITS data to Astro Pics for image processing, kind of a micro observatory deluxe? In fact, our micro observatory team has been working with Brandon and his team to identify NASA FITS data that we can actually put right in the image processing tool that micro observatory uses, but also create a kind of a curated data set for those of you who know how to work to do image processing with real data from our micro observatory telescopes. You can also do it with real data from NASA space telescopes, and we are going to make that available. So the answer to your question, Kevin, is yes. Other questions? Great. We'll look forward to seeing you in 2 weeks as we put the universe in context, and also to seeing you on the online community of practice. And it's really great to have all of you joining us, and we're looking forward to your ideas about how you would engage public audiences, or all different kinds of audiences in this content that is a key part of NASA discovery.